Welcome to tutorial on mastering Python's Lambda functions. Lambda functions are concise anonymous functions for quick tasks. In this tutorial, we will explore Lambda function syntax, their use cases, limitations, and how arrow annotations work in Python. In addition, we will also compare Python's Lambda functions with arrow functions in other languages like JavaScript. Lambda functions are small, anonymous functions defined using the lambda keyword. Unlike regular functions defined with def, lambdas are single expression functions without a name, ideal for short, one-off tasks. They are often used in places like sorting, filtering, or mapping. Let's look at a basic lambda function. Let's first define a regular function. Def square num colon return num multiplied by num. So this is a regular function that takes square of a number. So let's write equivalent lambda function. Square lambda equals lambda keyword using the lambda keyword x colon x multiplied by x. So they are the same. Let's print for each one, print square 5 and print square lambda 5. As you can see, the results are same. So at first, we find a regular function square that returns num squared. Second, we defined a lambda function assigned to square underscore lambda, taking x and returning x by x. Then we called square with 5, printing 25, and called square lambda with 5, printing 25. This lambda takes an input x and returns its square. It's equivalent of the square function but more concise. Lambdas are limited to a single expression, so they can't contain statements like for. Let's see lambdas used in functional programming. Lambdas shine in functional programming tools like map, filter, and sorted, where you need a quick function. Let's see a lambda used with map to double a list of numbers. So let's define a list named numbers equals 1, 2, 3, and 4. And double equals list list. So we will create a new list using the previous list using map function. Map function helps you to transform an iterable in Python. It's a built-in function and it can use lambda functions. And let's say lambda x x by 2 comma which iterable numbers. So the lambda is applied to each element in numbers. Map is perfect for transforming lists and lambda skip the code concise. Let's print doubled. It says 2, 4, 6, and 8. Lambdas are also great for custom sorting with sorted or sort. Let's sort a list of tuples by the second element using a lambda. Let's let's define pairs equals. This will be the list of tuples 1, 1, comma 2, 2, and 3, 3. Then define sorted pairs equals sorted. Sorted also accepts lambda functions, say pairs, key. It wants a key for sorting. So we can define something like this, lambda x1. It means that we extract the second element of each tuple for comparison, sorting the list alphabetically by the string. This is a common pattern in Python. Let's print it sorted pairs. print it. And as you can see, it says 1, 3, and 2. If I do it like this, change it to 0 and print it again, it sorts it numerically. So it's different than the previous one. Now let's compare Python's Lambda function and JavaScript's arrow function by demonstrating how each filters a list of numbers 1, 2, 3, 4, 5, and 6 to retain only even numbers, producing identical outputs 2, 4, and 6. In Python, the lambda function lambda x modulus 2 equals 0 is used with filter to evaluate each number, requiring a conversion to a list, and is limited to a single expression, reflecting its concise but restrictive nature. In JavaScript, the arrow function is used with the filter method, leveraging a more flexible syntax that omits parentheses for a single parameter and supports implicit returns, making it slightly more succinct. While both achieve the same result and excel in functional programming tasks, JavaScript's arrow function offers greater versatility, supporting multiple statements in example, and is commonly used in broader contexts like event handling, whereas Python's Lambda is tailored for quick, single expression tasks, highlighting their distinct design philosophies. In Python, arrow refers to the syntax used for return type annotations introduced in Python 3.5. These annotations specify what type a function returns, improving code readability and enabling type checking with tools like MyPy. Let's see a basic example. Let's define a function named def at a colon int b colon int and arrow. Be careful at this point. It's arrow syntax arrow int colon return a plus b. It's a regular function definition but with extra annotations. So now let's call it result equals at 3.4 print results. And if you run it, you can see the result is 7. The add function returns an integer. Annotations don't enforce types at runtime, but help with documentation and static type checkers. In order to use it with Lambda functions, let's see an example. While lambdas don't support direct type annotations, you can assign them to variables with annotations using callable from the typing model. Let's see an example. From typing, import callable query colon callable int and int equals lambda x x by x. So the first line imports callable from typing. The second line define a lambda assigned to square annotated as a callable taking an int and returning an int. So it will take an integer and return an integer. Now call square with 5. Let's call square with 5. So it will print 25. As you can see, the callable annotation means square is a function that takes one int and returns one int and returns an int. This combines the brevity of lambdas with the clarity of type annotations. So that's a wrap on Python lambda functions. We have covered lambda syntax, their use in functional programming and sorting, their limitations, and lambdas are great for quick tasks while annotations help with documentation and type safety. Try these in your projects and let us know your questions in the comments. Thanks for watching. If you liked the video, please subscribe to the channel and support us. Have a nice day.